Wizard. Welcome to another problematic video. I mean a video full of problems on parallelograms. In the last couple of videos, we discussed some really interesting problems based on the properties of parallelograms. And I have tried my best to elucidate how important the right approach is while solving a problem. Now, the right approach is something that can come only with constant practice, right? So, let's use this video to take some more interesting problems head on. Ready for another knowledge builder? Let's roll. The questions we are discussing today may seem to be a bit lengthy, but the trick lies in identifying which property of parallelograms would come in handy in solving the particular question faster. Also, some parts of the question may even be interlinked, so watch out for them. Let us now begin with the first question. It states that in parallelogram ABCD, 2 points P and Q are taken on the diagonal BD such that DP is equal to BQ. And we have to show the following. Quite a list, huh? Let us first draw the diagram for this question and then solve these one by one. So, we first make a parallelogram ABCD and then draw out its diagonal BD. Now, on BD, we mark 2 points P and Q such that DP is equal to BQ. Now, the question talks about triangles APD and CQB. So, we join A and P and Q and C to get the required triangles. Similarly, we join A and Q and P and C to get the other two triangles. The diagram is complete. Quite interesting, isn't it? Seems like a parallelogram inside a parallelogram. And if you notice, that's actually one of the requirements. We are probably on the right track. So let's get started with the solution. So, the very first requirement is to prove that this triangle APD is congruent to this triangle CQB. Now, which criterion of congruence do you think would fit here? RHS is obviously not possible since there's no mention of right angles. So, it's got to be any one of these. But which one? Let's just use the given information to find out. We can see that in triangles APD and CQB, AD is equal to CB since they are opposite sides of a parallelogram which, as we already know, are equal. And the question itself tells us that DP, which is the same as PD, is equal to BQ. So, we have two pairs of equal corresponding sides. We would need a third pair of equal corresponding sides to get SSS, or a pair of equal corresponding angles in between those sides to get SAS. We have no information about the third pair of corresponding sides. So, let's just try to prove these corresponding angles between the respective sides equal. So, how do we go about that? Well, if you notice, DB acts as a transversal between parallel lines AD and CB. Clearly, angle ADP and angle QBC form a pair of alternate interior angles. So, of course, they are equal. There you have it. Side, angle, side. Thus, triangles APD and CQB are congruent by the SAS criterion. Piece of cake, right? Now, the next requirement is even easier to prove because it's already solved. We just have to write that AP is equal to QC because they are corresponding sides of these congruent triangles. Now, moving on to the third requirement, it asks us to show that triangles AQB and CPD are congruent. Now, if you think about it, the exact same logic as the first requirement can be applied here. We know that AB and CD are equal because they are just opposite sides of a parallelogram, and diagonal BD acts as a transversal between parallel lines AB and CD. Thus, these two angles form a pair of alternate interior angles and hence are equal. And QB is equal to PD because it's already given in the question. So, triangles AQB and CPD are also congruent by the same SAS criterion. And now that we have proved them congruent, the fourth part of the requirement is automatically solved. AQ is equal to CP because they are corresponding parts of congruent triangles. Moving on to the last part of the requirement, it asks us to show that this quadrilateral APCQ is a parallelogram. So, how do we go about that? By now, we are experienced enough to predict that some property or condition regarding parallelograms may be applied here. But which one? Well, we don't know much about the angles or diagonals of this quadrilateral APCQ. We only have information about its sides, which we found earlier. So probably we are going to use a property or a condition that concerns the sides of a parallelogram. Here, we have already proved that AP is equal to CQ and AQ is equal to CP. Aren't these just the opposite sides of this quadrilateral APCQ? Of course they are. Remember the condition? If the opposite sides of a quadrilateral are equal, then it is a parallelogram. See, we just proved the fifth requirement. APCQ is indeed a parallelogram. That was child's play, wasn't it? Well, almost. We solved a complete list in under 5 minutes. You are doing good. But let's see if you can ace through the next question. It deals with a triangular prism. I'm not kidding, it really does. The question tells us that in triangles ABC and DEF, AB is equal to DE and AB is parallel to DE. Also, BC is equal to EF and it is also parallel to EF. And it's pretty evident that vertices A, B and C are joined to vertices D, E and F respectively. Now, we need to prove the following. Another list, another few minutes. Let's begin. The first requirement is to prove that this quadrilateral ABED is a parallelogram. We are obviously going to use a condition. So, what do we know about this quadrilateral ABED? Well, we know that AB is equal to DE and AB is parallel to DE. What else? Hey, why do we need anything else? If you notice, in quadrilateral ABED, AB and DE are opposite sides and we already know that they are equal and parallel. Remember the condition? If one pair of opposite sides of a quadrilateral is equal and parallel, then it is a parallelogram. Thus, ABED is indeed a parallelogram. The second requirement asks us to prove that BEFC is a parallelogram. Here too, it's already given that opposite sides BC and EF are equal and parallel. One pair of opposite sides is equal and parallel. So, BEFC is a parallelogram. So far, so good. Now comes the fun part, the third requirement. It asks us to prove that sides AD and CF are equal and parallel. So, how do we go about this one? Well, it's kind of intuitive. We just have to prove that this quadrilateral ADFC is a parallelogram. Thus, AD and CF being opposite sides of a parallelogram would automatically be proved equal and parallel. And we can prove that ADFC is a parallelogram using this information. No, this information. Wait, what? There's no mention of the angles, diagonals or sides of quadrilateral ADFC in the question. How then would we prove that ADFC is a parallelogram? Clearly, this is not the right approach. We have to try something else. Let's try to use what we have already proved and see if we can establish a connection between AD and CF. Well, if you notice, AD is actually a side of the parallelogram ABED, which means AD and BE being opposite sides are equal and parallel. Similarly, CF is a side of the parallelogram BEFC. So, opposite sides BE and CF are also equal and parallel. See the link? If we just name these equations as 1 and 2, we can use them to imply that since AD is equal to BE and BE is equal to CF, AD is also equal to CF. We studied this in Euclid's geometry, remember? Things which are equal to the same thing are equal to one another. Who knew we could use it here? Anyway, coming back to the question, since AD is parallel to BE and BE is in turn parallel to CF, it just implies that AD is also parallel to CF. So, AD is equal to CF and AD is parallel to CF. There you have it. We just proved this one too. The fourth requirement is duck soup now. I mean, it's easy peasy. We just proved that AD and CF are equal and parallel. And since they form a pair of opposite sides of this quadrilateral, it's obvious that ACFD is a parallelogram. The fun part here is we unknowingly proved the fifth requirement as well. We needed to show that AC is equal to DF. Now, we just proved that ACFD is a parallelogram, so its opposite sides AC and FD would obviously be equal. We finally come to the last requirement, which asks us to show that these triangles ABC and DEF are congruent. This one's as easy as ABC. The question itself tells us that AB is equal to DE and BC is equal to EF, and we just proved in the fifth requirement that AC is equal to DF. So, side, side, side. Thus, these triangles are congruent by the SSS criteria. So now, all the requirements of this question are proved, so our question is solved. Whoa! We got to the end of it already. You are on fire. Or should I say, you are lit. Well, I just love how this question indirectly teaches us so much about triangular prisms. We saw that the triangular bases are identical and all the lateral faces are actually parallelograms. Fascinating, isn't it? As you keep practicing, you will come across such amazing questions. The best part, there's a galore of such interesting questions right in your app. What keeps you here then? Go, 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 practice. And I'll see you in the next one. Till then, take care and goodbye.